Good morning, everyone. Any doubts from the previous class? Want me to repeat any part of the theory for you to understand the types or how the size is determined? It's very easy to score in this subject unless and until you know the theory part of this chapter, because you can expect one question in 2 marks question, that is section A, and section B you can expect one question where I think it's easy to no, at least read the types of sampling distribution, the probability sampling distribution, non-probability, and just explain them. No doubts? So let us start with the problems. Yesterday we solved one problem. We were starting to solve the second problem yesterday. Okay, let's continue from the second problem. Now, if you see the second problem, the sample of 200 chocolates had a sample standard deviation of 0.4 grams. So the chocolate sample, there were 200 different chocolates that were there as the sample. So the standard deviation of this sample was 0.4 grams. How many chocolates must be included in the sample if the investigator wants to be 90% confident that the sample mean is within 0.1 grams? So it is something like we are very confident about what will be the result. Now, what is the result? We are saying that we are 90% confident that the result is going to be 0.1 grams. That is the mean. So there were 200 chocolates. There were 200 chocolates which was taken as sample. Now for this, the standard deviation was 0.4 grams. We knew the standard deviation. So what we are saying is the mean is going to be, the sample mean is going to be, okay, 0.1 gram. And how confident are we? We are 90% confident that it is going to be 0.1 gram. Okay, and the Z value is given to us. In every problem, they'll give you the Z value. Okay, so here what we are supposed to do is, since, see, there are two types of problems. Type number one is when the standard deviation is given, and type number two when the population proportion is given. So here we are solving the standard deviation problems. So write down the Z value, that is 1.64, standard deviation value 0.4 grams, and then the standard error. Now, how do I know standard error? I am 90% confident that the mean will be 0.1 grams. But out of 100%, there is still 10% which is remaining. So 10%, 10 divided by 100, which will give me 0.1. So this is the standard error, which is denoted by small e. So I take that as standard error. Now we have a formula to find the sample size. That is nothing but n is equal to z into standard deviation divided by standard error whole square. Let us apply all the values. We know z value is 1.64, standard deviation is 0.4. So 1.64 into 0.4 divided by the standard error is 0.1. It is not this 0.1. Okay, it is not this 0.1. It is this 0.1 which we are talking. Okay, then whole square. If you simplify this, first multiply. 1.64 into 0.4. You'll get one number. Then divide that by 0.1. And then whatever number you get, square that. So you get 43.0336. So if you see here 43.03. So you can take 43 as the sample size. Don't take the decimal part. Keep the sample size as whole numbers. Okay. Suppose if I want to take the sample of human being. Okay. If I call 10 people, I can take the sample as 10 people. But can I call 10.25 people? I cannot call 10.25. Don't say me 10 people plus a baby. No, that is not the concept. So the sample sizes, keep it as much as the whole number. Don't include decimals. Okay. Since here after the point you just have 0. So you can take 43 as the whole number. So the sample size that if you take 43 as the sample size, then the mean for that will be 0.1 and 0.4 will be the standard deviation. So the ideal sample size out of 200 chocolates is 43 chocolates. So this is the sample size. Understood? Any doubts in this problem? Everybody understood? Good. Now, moving on to the next problem. The standard deviation of the marks of the students is 60. So in a class, let's say there are many people. We don't know how many people are there yet. So the standard deviation of the marks of the students was 60. Okay, so standard deviation is 60. The teacher wants to know the average marks of the students. So the teacher wanted to know the average marks. Average marks is mean. Okay, the teacher wants to know average marks of the student. How large a sample is needed to be 95% confident, okay, that the sample mean will not differ from the population mean by more than 10 marks. Okay, so what they are trying to say here is how much should be the sample wherein I am 95% confident. Okay, I am 95% confident that the sample mean will not be different from the population mean. So I told you there is something called sample mean and there is something called population mean, which is nothing but mu. Okay. Now the difference between sample mean and population mean will not be more than 10 marks. It means the difference between, the difference between the standard mean and sample mean and the population mean will be either equal to 10 or it will be less than 10. I'll repeat the question again. Listen carefully. The standard deviation of the marks of students is 60 and teacher do not know what is the mean. This is not known. They are asking us how many students are there in the sample wherein the teacher is 95% confident that the difference between the sample mean and the population mean Okay, it will not differ from the population mean by more than 10 marks. So they have given us the difference between x bar and mu to be 10 marks. Okay, so this can be considered as the margin of error. Okay, let's just check the double verify the calculation here. Sometimes there would be printing mistake which will be done. Yeah. So since they have given us the difference between the population mean and the standard population mean and the sample mean. So this 10 marks, we will take it as the standard of error. So if you go back to the formula here, it says E is the margin of error. How much plus or minus can the sample size be? Okay, how much plus or minus can the sample size be? That is what we are trying to find out. So in these problems, you would have taken or you can even consider these values. But in this problem, they have clearly given that the difference between the population mean and the sample mean will not increase more than 10 marks. So you can directly take 10 as the standard error. Did you understand the question first of all? Everybody understood? You want me to repeat it again? Okay. Okay, there can be a plus or minus of 10 here. So that is E. So N is equal to, if you do the calculation and simplification here, 1.96 into 60 divided by 10 and then square them, you get 138.29. So the sample size, again, leave out the decimals, take the whole number. And because after point, you have the number less than 5. So the sample size is going to be 138. So this is the sample size that we have found out. So for 138 students, the teacher wants to know the average marks for this. So they have the sample size to be taken for that average is 138 students. So if you just write the sample size is 138, that is more than enough. Understood? Clear with this problem? Can we go to the next problem? Okay. Now the next problem. The employer wants to check the proportion of people. Now, if you understand, until now, we solved the problems where direct standard deviation was given. That was type 1 problem. Now, the next type of problem is when population proportion, okay, something called as population proportion will be given to us, and we have to find the sample size for the population proportion. So let us read the question. The employer wants to check the proportion of people in a given job application. He wants to see how many of them have applied, how many male, how many female, okay, all that proportion. The company has received 200 application. So they have received totally 200 application, out of which there were 120 people who are male employees. Okay, 120 people are male employees. The employer wants to know population proportion P to be within 0.15. So one thing what you will have to understand and catch in every problem is whenever they have given you this 0.15, it says within, not more than, not less than. If you find such words, then in that case you will have to take that number, that is 0.15, as the margin of error. Understood? 0.15 as margin of error with 90% confidence level. So they are 90% confident that they want to see the population proportion P should be within 0.15. What is the minimum required sample size for the survey? So my total population, the total number of people are 200. Out of 200, 120 are male employees who have applied for the job. Now, the employer wants to know about the population proportion, and the population proportion is denoted as P, capital P. And they are saying that the capital P will be within 0.15. They are also not sure, not 100% sure. They are only 90% sure, saying that it is within 0.15. Okay, and they are asking us what is the sample size that we require to calculate this all data that we have given in the question. So Z value is given. There are 90%, 95% tables where you will find the Z value. So Z value is 1.64 and population proportion P. Now let us see how to calculate P. We know that from the question, we know that 120 are male employees out of 200 people. This is one of the proportion that I know from the problem. So 120 by 200, 0 and 0 will get cancelled. So 12 by 20 will give me 0.6. So this is the population proportion that we have here. And if you see, they are saying that the population proportion will be within 0.15. Okay, so what is the limit for us? The highest value that this population proportion can go is 0.15. So that is why we have taken that 0.15 as the standard or margin of error. Did you all understand the question? Okay. Now the rest is only application of formula. So if you see the formula for this, it is n is equal to z square p into 1 minus p divided by e square. So z value is 1.64. So 1.64 square into P we have found out by the given proportion. There were 200 applications. Out of that 120 were male. We know one proportion. So 0.6 into 1 minus 0.6 divided by E value is 0.15 square. Okay, 0.15 square. Now simplify. 1.64 square into 0.6 into 1 minus 0.6 is 0.4 divided by, find the square here. So you get 0.0225. And then when you multiply all this with the squares, you get 0.6455 divided by 0.0225. And when you divide these two, you get 28.6889. Now, if you see, the after decimal, the number is more than 5. If after decimal, the number is more than 5, you can round off to the next number. So your sample size is 29. So if the sample size is 29, then the population proportion P will be within 0.15. Okay, I'll repeat that again. If the sample size is 29, that is the minimum sample size. If that is 29, then the population proportion will be within 0.15, and we are saying that with 90% confidence level. Understood? No doubts? Sure, everybody understood? Okay. Then let's go to the next question. Now, the company wants to estimate. So if you see here, it just want to find out proportion, estimation, all are in the same manner, right? So the company wants to estimate the proportion of, see, proportion problems, directly they give it as proportion. Okay. So in the standard deviation problem, they will directly give you the standard deviation. So the questions are very direct. So you should be able to answer them directly instead of thinking too much. Okay. Now, the company wants to estimate the proportion of customer satisfaction for the new product launched. So they have launched a new product. They want to understand the customer satisfaction. Now, there is some proportion in that. Let us see what is that. The company wants to estimate the proportion of customer satisfaction for the new product launched within 3 percentage points. So this is the criteria, 3 percentage points with 99% confidence. Prior studies means previously some studies had done, showed that 65% of customers are satisfied with the new product. So they're launching a new product with some 3 percentage points criteria, and previously when they had done some trials, they understood that 65% of the customers liked the product. They were happy with the product. How many customers should they sample to estimate proportion of customer satisfaction? So before, some product which was done, there it was 65%. But now they're asking, how many people should I go and ask if they're okay with the product? Okay, you cannot just go and ask some 1 lakh people. It is not feasible. Practically, it is not possible. Okay, so I will find out some proper number where I can get the feedback and start analyzing the feedback. So they're asking us, what is the number? Then confidence coefficient of 99% is 2.575. This is nothing but Z value. So the Z value that is given to us is Z is equal to 2.575. Okay. So what is the first thing? We have 3 percentage points. Before, there were 65% of the customers who were happy, and now we have to find out how many we have to get the opinion. So we directly know what is the Z value. So Z is equal to 2.575. Now population proportion. Now population proportion is, it says prior studies, previously when they did, 65% of the customers, see, this is the catch, 65% of the customers. So 65%, percent means divided by 100. So 65% of the customers were happy. So 65 by 100 will give me 0.65. That is the P value. This problem looks a little different, so please understand the problem well. Okay, so 65% of the customers. And then they have told us they have launched with 3 percentage points. 3%. There were 3 different criteria of percentage. So that 3% is 3 by 100, which is 0.03. That is the margin of error. Did you all understand until here? Any doubts? Any part you want me to repeat it again of this question? Everybody understood? Okay, good. So now let us go to the formula. Everybody is clear that it is a population proportion problem. So the formula will be n is equal to z square p into 1 minus p divided by e square. So z square is 2 point, this is a little dull here, so please write it down properly. 2.575 0.575, okay, square into 0.65 into 1 minus 0.65 divided by 0.03 square. Now if you simplify this, you get 1676.07. Yeah, 1676 point, 1 second, let me clarify that. Yeah, 0.07. This is supposed to be 1676 only, not 8. Correct this also. You cannot round it off to 2 numbers and all. Okay. So you can just round it off to that number, and moreover it is 1676.0. The number is less than 5. So the sample size is going to be 1676. So 1676 is the number. If I ask 1676 people about the product, I will get the proper review of the customer satisfaction. That is what is the meaning of the sample size. Understood? Practice this problem a little, because the wordings sounds little confusing. The wordings may sound a little confusing. Practice this problem. Okay. So any doubts in this problem? So can we go for the next one? Can we go for the next question? Now, a man wants to check inventory records against a physical inventories by a sample survey. Permitted deviation is plus or minus 5, and the standard deviation is 19.7. So by seeing the question only, you will be able to understand that this is a direct standard deviation question. Now the problem which we solved before was a population proportion question, because it talked about proportion. Proportion is in comparison. Now in a class, if I say the proportion of boys and girls, how many boys and how many girls are there? That is the proportion. Now, but here they are directly talking about standard deviation of the data. So a man wants to check inventory. Inventory means stock records against the physical inventory. Physical inventory means directly going into the go down and counting each and every product is the physical inventory. Okay, many times whatever is physically present there will not be in the books, or whatever is present in the books will not be there in the go down. So he wants to compare both of them. He wants to compare the books as well as physical stock, and he wants to make a survey. A sample has to be taken, and there will be a difference of plus or minus 5. That is what he has given directly. So survey permitted deviation. Survey permitted deviation is plus or minus 5. There can be a plus or minus, up and down of 5. Find the sample size if the confidence level is 90%. Value of confidence coefficient is 1.64. So what is this 1.64? Okay. Coefficient is 1.64. Now 1.64 is the Z value. So confidence coefficient is 1.64, which is the Z value. And then standard deviation is 19.7. Okay, and then the error, permissible error, they have told, right, there can be a difference of plus 5 or minus 5. So what we have taken is that plus and minus is already included, so I will only take the number, that is 5. Now, since this is a direct standard deviation problem, the formula for that will be n is equal to z into standard deviation divided by the error of, the standard error to the power square, margin of error to the power square. Then if you simplify this, you get the sample size of 41.7522. So after a point, the number is more than 7. So it should become 42. Round it off. If the number after decimal is more than 5, then round it off. 41.5, 42. 41.4 means 41 only. Okay, 41.6, 42. 41.7, round it off, 42. Here 41.3, 41 only. Did you understand? If it is 5 or more, then you can round off to the next value, that is 42. So the sample size should be 42 for him to check the records in the books as well as in the go down. He's just comparing both of them. Understood this problem? Any doubts here? Everybody understood? Okay, now coming back to this problem, one of you wanted me to repeat the last part. So listen. So a company wants to know the proportion of the customer satisfaction. Let's say they have sold refrigerators, fridges. Now they want to know the feedback, how the fridge is working. Okay, now the before product, before fridge and all, 65% of the customers were happy about the working of the fridge. So they are all fine with that. Now, with this new product also, they wanted to know what is the feedback. Now, I wanted to see how many people should I ask to get the feedback. Okay, and the important numbers are the product is launched with 3% points. So this is some kind of a customer feedback points, that is 3%. So this 3 percentage points will become the error, margin of error. Okay, and then the population proportion is 65% of the customers who were satisfied with the product. So that is population proportion. Then the Z value is directly given. Now put all these values into the formula, and that is n is equal to Z square P into 1 minus P divided by E square. Now here the numbers are a little blurry, so please write down the numbers and calculate. And when you get the final answer, the answer is 1676.07. so the sample size is not this, but the sample size should be 1676. Okay, so the sample size is supposed to be only 1676,